Good afternoon. We are going to be going through how to write the equations of a line using a variety of forms and a variety of starting information. We're also going to go through labeling types of correlations. There is a file that you can download and print that has all of the types of correlations written out and graphed. That way you don't have to do it yourself. Okay, so we're going to just number our different problems. So number one, we're going to calculate slope from 2 points. So to do this, you definitely need your slope formula. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You can switch the points. Just make sure that point 2 comes first, point 1 comes second on both the top and the bottom. So we're going to use the points negative 2, 1 and 5, negative 3. I'm going to designate them in order, x1, y1, x2, y2, and insert them into the equation. So y2 is negative 3 minus y1, which is 1, over x2, which is 5, minus a negative 2. Notice there's a negative from the formula and a negative from the 2, so you have a double negative there. Negative 3 minus 1 is negative 4. Of course, a negative times a negative is a positive, so 5 plus 2 is 7. Our slope is negative 4/7. Okay, so number 2. This type of question, they want you to solve for x, and they're going to give you the information that you have a line passing through 2 points, negative 8, negative 2, and x, which is unknown, comma 2. And then they're also going to give you, let me put example there, they're going to give you the slope, which is 1/2. So what you're going to do with this is you're going to use the same slope formula, but you're going to use it to solve. So for the slope on the left, I'm going to have 1/2 equals, and again, I'm just going to designate in order x1, y1, x2, y2. So on the top of the fraction is y2 minus y1, so 2 minus a negative 2. On the bottom, x2 minus x1, x minus a negative 8. Be really careful with those negatives. Okay, negative times a negative is a positive, so we can do a little simplifying. So 1/2 equals 4 over x plus 8. Now, we want to solve for x, so one really nifty solving move is flippy step. Flippy step works if you have a fraction equaling a fraction. You can just flip both sides. So now I've got 2 over 1 equals x plus 8 over 4. All right, so our next job is to get the x plus 8 by itself. So we're going to multiply by 4 over 1 on both sides. So now we have 8 equals x plus 8. You can probably see the answer by now, but if you subtract 8 over to the left, we've got 0 equals x. So our answer is x equals 0. All right, number 3. We are going to find the equation of a line in general form. So the equation in general form. And to remind you, general form of an equation, there we go, is capital AX plus BY equals C. Typically what we do is we find the equation in point slope form, y equals mx plus b, and then we transition it to that form. So on this one, we're given the points negative 1, negative 5, and negative 4, negative 2. The first thing we need to do is find the slope. So we designate our points, x1, y1, x2, y2. So on the top, y2, which is negative 2, minus y1, which is negative 5, over x sub 2, which is negative 4, minus x sub 1, which is a negative 1. Of course, a double negative multiplies to give you a positive on the top and the bottom. So 5 minus 2 is 3. Negative 4 plus 1 is negative 3. We have a slope of negative 1. I'm a little bit out of space here, but what we need to do next is we need a temporary xy because calculating the y-intercept doesn't have a formula, so we have to solve for it. So we're going to substitute in the point of our choice and the slope. I'll just pick the first point as my temporary x and y. So negative 5 is my y equals my slope, which is negative 1, times my temporary x, which is negative 1, plus b. So negative 1 times negative 1 is positive 1. So negative 5 equals 1 plus b. Subtract 1, we get negative 6 equals b. Once you have that, let me switch to another piece of paper here. Once you have your b value, we're now ready to build it in slope-intercept form. So y equals my slope here, which is negative 1 times x, plus b, which is minus 6. Now, to put this into standard form has no fractions, and the a has to be positive. Those are the only two requirements that we have. And then you put it, of course, into the form ax plus by equals c. So what we're going to do is just move our x term over. So we're going to add x over to the left. So x plus y equals negative 6. My a term is a positive 1. So we're good to go. If you had a fraction that you needed to get rid of, you would do a common denominator and then clear the fraction. All right, number 4. We're going to find the equation of a line in slope-intercept form. This is a really easy one. Slope-intercept form is y equals mx plus b, where of course m is the slope and b is the y-intercept, and that's how it gets its name. Oops, sorry, I'm off my screen. There you go. So we've already pretty much done one on the previous example where we started with 2 points. Sometimes, though, they're going to be nice to you, and they're going to give you a point and the slope. So we have the slope, but again, we need the y-intercept, and there's no formula for that. So we're going to take this point. It's going to be my temporary xy, because you know x and y represent infinite points. I'm going to temporarily replace them with this point. So 2 equals slope, which is 1/2, times x, which is 1, plus b. So my temporary x and y in order to find the b value. All right, so 1/2 times 1 is 1/2, so I'm going to subtract 1/2 over to the left. Let's see, 2 is over invisible 1. We need a common denominator. I need the bottom to be a 2, so I multiply the top and the bottom by 2. So 4 minus 1 is 3/2. That's my b value. So my equation is y equals slope 1/2 x plus 3/2 for the b value. All right, example number 5. We're going to find the equation of a line. This time we're going to do it in what's called point-slope form. And the formula for point-slope form is y minus y sub 1 equals m times x minus x sub 1. And what you need for this form is you need m, which is the slope, and you need 1 point. And it can be any point that the graph passes through. And that 1 point we call x1, y1 in the equation. So for example, let's say that we have the point -3, 4, and our slope is 3. Now, if they don't give you the slope, you will calculate it from the 2 points, and then you'll pick one of the 2 points to go into the equation. It doesn't matter which points you pick. Point-slope form, there are infinite forms for this type of a line equation because it can be any point, you can have anything in there. The slope will be the same, but the point will change. Now, this is unlike slope-intercept form. This form is unique. There's only one formula for one line. Standard form, which is this one, or general form, this one is also infinite forms because you can multiply A, B, and C by any number you want. So that's infinite. The only one that we have that's unique is slope-intercept form, which is why 9 times out of 10 we answer with that form to check our work. All right, let's go back to point-slope form. I'm going to substitute in my point. So this y and this x do not change. So y minus 4, there's our y sub 1, equals my slope, which is 3, times x minus a -3. So I used this as my temporary point, or sorry, as my 1 point, x1, y1, and the slope. And then you just simplify any double signs. So this is x plus 3. And that is the form of the line. Okay, last one, number 6. Last type of question you need to do is you're going to need to work in function form. So there's a couple things you need to know about function form. Here's an example. F of A equals B. Function form, the left side tells the story. It's not math, it's a description. So a description, not math. So what does this tell us? This says that this is the name of the equation, which we're now calling the function. This is lowercase f. A is what is substituted for x, and b is what is calculated from x. In other words, b is your y term. It's what you get from the x. X creates y. So for example, if I show you something like f of -2 equals -4, this is the x value that was substituted into the function. This was the y. This is function form. In Cartesian form, it would be -2, -4 with the x and the y. It really is just a different notation form. All right, so the example we're going to do is, let's see, f of -3 equals 5, f of 6 equals -2. And we're going to write the equation of the line in slope-intercept form. So slope-intercept form, of course, is y equals mx plus b. So first thing we need to do is calculate the slope. And so I need points for that. There is no slope formula in function form. So -3, 5, -3 is the x, 5 is the y. So the point is really -3, 5. F of 6, the x is 6, the y is -2. We have 6, -2. So x1, y1, x2, y2. Once we're in Cartesian form, we can crank it through our slope formula. So slope equals y sub 2 -2 minus 5, which is y sub 1, over 6 minus a -3. -2 minus 5 is -7. A negative times a negative is a positive. 6 plus 3 is a 9. I have the slope. So now I need to find the y-intercept, or the b value. So I'm going to pick a temporary point. I'll just pick this one, and my slope, and I'm going to substitute it into the equation. So my temporary y is 5 equals my slope, which is negative 7/9, times my temporary x, which is negative 3, plus b. I substituted it in. Now we solve for b. Let's simplify though. Negative times a negative is a positive. 3 goes into 9 3 times, so 7/3. We're going to subtract 7/3. Give your fractions enough room to breathe. 5 over 1 needs a 3 on the bottom, so we multiply by 3 over 3. 15 minus 7 is 8. 8/3 equals b. Now that we have our b value, we can write our equation. Y equals negative 7/9 x plus 8/3. If you wanted to write this same equation in function form, it would be f of x equals negative 7/9 x plus 8/3. By putting the x in instead of a number, what we're saying is that there are infinite x values possible. We just haven't done them yet. All right, that concludes our note taking for today. I hope that was helpful. Have a good afternoon.